So good afternoon and thank you everybody for attending our sixth UK and Ireland VCF enablement webinar series. Hopefully you've all been able to get away during August whilst the weather was good. I know the last few days it's not been great in various parts of the UK. My name's Carl Babington. I'm one of the solution architecture managers here at VMware by Broadcom, and today we're going to hear again from Duncan Appleby on storage flexibility with vSAN storage clusters and VCF9. So nice new VCF9 capability. But before I hand over to Duncan, I'm assuming no one on this webinar was in Vegas yesterday. If you were, I'm suspecting you're really tired, and thank you for joining. It's very dedicated. But for the rest of us, you can go back and watch the general session. The other session recordings will be available from the 1st of October. I'll post the links in the chat in a moment. And if you are looking to try and see if you can get yourself out to Vegas for Explore next year, the date's been confirmed as the 31st of August. So there was a lot covered in Explore, a lot of new capabilities, talked about the direction of the platform. I'm not going to go through those during this call. Obviously, this is more to go a little bit more in depth, which we will do with Duncan. What I wanted to call out is, I know we've been mentioning Explore on Tour in London. We have now filled registrations for that. So if you have been holding back on getting a ticket for Explore on Tour, apologies, the registration has been filled up now. But what we can say is that there are still tickets available for the UserCon. So next slide, Duncan, sorry, mate. So Explore on Tour registrations are still open for the UserCon, so there's not that many places left. So if you would still like to be able to get down and hear from a great list of speakers, then please register for the UserCon. The agenda has been published now, so you can go through, look at the agenda, and then register for that. So as usual, feel free to ask Q&A questions in the Q&A panels. We've got people in the back who will be able to field those for you. And yeah, hopefully you enjoyed today's session. So Duncan, please quick intro and let's kick us off.
Great. Thanks, Dr. Carl, and welcome everyone to the next session of the webinar series. As you can see, we're talking about storage clusters today on the VCF9. My name's Duncan Appleby. So the very first thing I think we probably need to do, we're going to hear about disaggregation and disaggregated storage quite a lot during the next 30 minutes or so. So first of all, I'm just going to define disaggregation as far as VMware by Broadcom sees it from a vSAN storage perspective. And really, it's quite simple. It's separation of compute resources from storage resources. So we'll talk about why disaggregation and how we got here, and what disaggregated storage means from a vSAN perspective. So for the last 10, 12 years, we've certainly been running vSAN under HCI, so hyper-converged infrastructure. And that came about, was introduced to the market, really from the challenges that existed with three-tier architecture. So compute, storage network, and then your storage system as well. Generally, we were something we were running for a long time under vSphere environments, but that generally came under proprietary hardware, so dedicated storage systems that were incompatible perhaps with other storage systems inside the environment. There was definitely limited scale in those architectures. So I certainly remember working with customers whereby when we reached a certain scale point within inside an array, we had to go through procedures such as head swaps or entire replacement arrays before we could expand those with more storage. Siloed management was a huge problem as well. So if we think about what was going on then, virtual infrastructure teams became the major consumers of storage within inside an environment, and often that team that managed the storage sat outside the virtualization team. And the last point on this list, limited to the data center. I think now quite common to be able to find array type storage addressable across wide area networks, but certainly back then, really no ability to have the same storage in both on-prem and off-prem locations. So there were some of the reasons that really VMware vSAN came to market and started to answer some of those, and it's been great for the last decade or so. However, there are challenges with aggregated HCI infrastructure. And over the last couple of years, we've introduced a new disaggregated version of vSAN that helps to address some of these challenges that customers have brought to us. The first is limited scaling of compute and storage independently. So what's really happened is perhaps customers who have dedicated data centers to HCI infrastructures, but then a system comes along that has extreme growth in storage, and that ends up with a disproportionate growth inside of our HCI environment. We tend to add nodes of compute and storage whereby the compute isn't really needed. We end up with stranded capacity, so compute being utilized at 20% and storage at 70, 80. There's also the limited capability inside HCI infrastructures to actually export that storage to other clusters. So vSphere clusters are quite possibly used as part of a storage refresh. We see an array refresh coming up where we want to deploy vSAN. Is HCI really the best infrastructure to share that storage across into that environment? So the answer from vSAN today is a disaggregated version of vSAN. It's not a different code version. It's simply a different architecture to run vSAN within inside your data center. If you choose to deploy disaggregated versions of vSAN, then the benefits we'll really see from that is fixing that problem of scaling compute and storage independently. And we'll show you some of the next few slides about what that looks like and how we can expand those. The vSAN storage cluster capability comes under the same management as vSAN. So if you're used to managing vSAN in your environments, or if you're certainly used to using vCenter as the administration tool, then disaggregated storage with storage clusters will appear in the same location. And all of these capabilities, it's really about driving down cost. If we are no longer having to procure hardware that has excessive compute or storage capabilities, we can simply procure what is needed for the right components within inside the data center. So let's talk through the different options that are now available. So on the left-hand side is kind of what I've been referring to as HCI. Pretty familiar for most of you, certainly for those using vSAN, is that we run compute nodes that have storage inside them, and our virtual machines run on that same environment. There's definitely a halfway solution as well, something called data store sharing with HCI. This is where we can have two hyperconverged environments running vSAN storage, and we can share storage from one to the other. I typically see this used in VDI environments. It's quite common. So an organization will seek to have commonality against their nodes they're procuring for their VDI environment. So the same node containing the same type of disk, CPU, and memory. But what they will start to build out is perhaps a developer VDI environment has different requirements from perhaps the finance team. The developer environment has greater pressure on storage, and maybe storage is constrained in that environment. In this example with data store sharing, we can borrow some of the storage from perhaps that finance environment, share it over the network into the HCI one. I'd say it's good for solving small problems, but it's not great as a permanent solution. If we think about sharing storage across environments, can bring complexity. Perhaps we know that the finance cluster is not being used over the weekend. Someone makes a decision to just restart the hosts, not affecting anyone using a VDI solution, perhaps forgetting that storage is actually shared elsewhere inside the environment. Some of the solutions to that, and solving on some of those problems, is the disaggregated storage or vSAN storage clusters. We can present this storage out, and we'll show in a couple of slides' time as to how it can be consumed. But the important thing to understand is that when we share storage from a vSAN storage cluster, it can be consumed by a compute-only cluster. We do not have to deploy vSAN on that cluster, not vSAN OSA original storage architecture or vSAN ESA express storage architecture, just pure vSphere and consume that vSAN data store. We can also get quite creative with networking when we separate these two out. And towards the end of this presentation, I'll touch on some of the things that we can do in that regard. So everything I've mentioned for the moment has been around vSphere, but let's look at how this can be consumed under VMware Cloud Foundation. So in actual fact, all the three ways that I've mentioned previously, we can consume storage inside a VCF environment. So that aggregated resources, that HCI with data store sharing, and a vSAN storage cluster. So within inside a single VCF instance, we can have multiple workload domains, multiple clusters, each consuming different types of storage, and indeed sharing different types of storage resources. And obviously the advantages from a vSAN storage cluster is that we can scale that compute and storage independently. What I'm going to touch on now is why we'll choose VCF and vSAN, specifically vSAN storage clusters, over perhaps a traditional array. The first one is really end-to-end visibility. If we think about what happens with a traditional storage array, it generally handles all I/O equally. And when we pass off traffic from inside the hypervisor and perform a write or indeed a read from an array, the intelligence around what's happening there is lost. vSphere can no longer see what is happening. The storage array simply handles that. So if latency or an issue is introduced, vSphere just sees it as a latency problem and doesn't really understand what's happening from a storage array perspective. From an HCI perspective and from a vSAN storage cluster perspective, we retain full visibility across the entire I/O path. So the hypervisor has really good understanding of information about the virtual machines as they're reading and writing data. But that doesn't just stop at the network port or fiber channel card. When we're writing to disks and we're writing across the network as well, vSphere and vSAN retains all of that visibility. And because of that, we can control it as well. If we can identify where contention is within inside the stack, we can do something about it. Perhaps we can put an I/O limit on a particular virtual machine. Perhaps we need to pause a particular process to ensure that virtual machine traffic gets priority. We can't do that in an array-based system. As I say, that intelligence is lost beyond the port as we pass it off. So spoken about a little bit about the different options available. So how do I choose what is best for my environment, right? Should I choose vSAN HCI or should I use a vSAN storage cluster? So some of the questions in this box will really guide you as to the right kind of platform for your environment. So the first of all is, do I have asymmetric growth of compute and storage resources? One of the tools inside the VCF product set, certainly the vRealize suite of products, and vRealize operations is going to help identify that. We'll be able to see how storage is growing. We'll have trending and predictions on when we're going to exceed perhaps limits of existing environments. We also want to understand, do we have requirements for storage for existing clusters? So that question is really perhaps, we have an array that's reached the end of life. I need to refresh that, but my compute environment remains fully supported and still has a number of years to go in terms of support. So for that example, we might be better deploying a vSAN storage cluster to meet the needs of those individual vSphere clusters. The final thing in this list is the topology requirements and constraints. And that's really just understanding where the limits of a vSAN storage cluster are. Perhaps if we've got a large amount of very small clusters, maybe single CPU, maybe 128 gig of RAM, legacy hosted inside the environment, hosting a small number of virtual machines, that might not be a good match for a vSAN storage cluster. There are limits. We can connect 128 hosts to a vSAN storage cluster. So really, we're looking at large capacity from a compute perspective to build out really capable environments. That doesn't mean that those small systems can't run vSAN, but we're probably perhaps looking at alternative, maybe to insert NVMe drives into those hosts to provide HCI storage. And across all of that is capacity. We do need to recognize that a vSAN storage cluster has a minimum entry point. We are not talking about a few terabytes of storage here, probably dozens towards hundreds of terabytes as a starting point. And then from a scale perspective, we really are talking petabyte scale. So some choices need to be made, but I think with those sort of three elements, along with the kind of capacity, you probably guide yourself to one of these two different solutions that might make sense. And the rest of this diagram really just builds out and from what I'm talking and guides you towards vSAN storage clusters or HCI from an architecture perspective. So we now know that a vSAN storage cluster is purely for providing shared storage. But that shared storage has all the capabilities of vSAN itself. So if you know vSAN ESA Express storage architecture today, you'll know that we have a really powerful and fast snapshot engine, and that can be used within inside our storage cluster. And if we're adding vSAN data protection, we can have up to 200 snapshots per virtual machine and mutable snapshots as well. It retains the ESA communication stack. So if you've moved from OSA, original storage architecture, to ESA, and you've seen massive improvements in speed and response times and scale inside your environments, you'll observe those with storage clusters as well. We're also able to have the same storage policies. We don't administer a vSAN storage cluster in any different way from an HCI one. If you're used to managing vSAN policies, It's just another policy we apply to this storage cluster. And there's flexibility as well. Single site, multiple site, stretch clusters, all available. You'll see in the lower half of this diagram, it says supports high density ESA nodes. So yes, there is a differing set of hardware to run an ESA storage cluster. And towards the end of this presentation, I'll touch on the hardware choices we have. Just for a second, I know there's a team behind that are answering questions. So if you do have anything about, if you do have any questions about anything I've spoken about already, please just drop something in Q&A and the team can answer it. So let's now have a look at vSAN storage clusters, some of the terminology and how they can be brought into an existing environment. So on the top half of this slide, you'll see the notion client clusters. That something that a cluster that connects to a vSAN storage cluster within vSphere is known as a client cluster. And those client clusters can be a standard ESA cluster, compute cluster, or indeed a stretched vSAN ESA cluster. So if you're already quite mature with your vSAN ESA deployment, you have stretched across sites, you can still consume storage from a vSAN storage cluster. From the lower half of the diagram, what can we do from a vSAN ESA perspective? Yeah, two different architectures as well, stretched and non-stretched. What I'm really trying to get across here, there's a huge amount of flexibility in both the source and the destination when it comes to vSAN and vSAN storage. On the left-hand side, you'll see a note here saying same or different vCenter server instance. So for the client and server clusters I've just listed on here, those could be managed independently by completely different vCenters. They could be in the same workload domain across different workload domains in VCF. So we really can present that storage to the needs of the workloads and the clusters that we've architected. So with the most recent release of VCF, VCF 9, we brought into vSAN the ability to do deduplication. You'll see at the very top here, so cluster-wide deduplication, but limited availability. So in the initial 0.0 release, we've made it available and we're working with a small pool of customers to actually enable deduplication of vSAN ESA inside their environment. The idea being that with the next release, it'll be fully available to all vSAN ESA customers. And of course, it also applies to storage clusters as well. And the kind of feedback we've seen in testing and the kind of feedback we're getting from customers as well, we're seeing great deduplication ratios. And I expect that we'll probably start to be talking about this, certainly from probably on our blog articles, start to see dedupe ratios as powerful as 8-to-1 inside vSAN ESA. In terms of how the granularity or how deduplication is working, so very small 4K granularity and across the entire cluster. If you're used to vSAN today and you've been working with OSA, you might be aware that deduplication happens on a disk group level. But inside that, we have multiple disk groups inside a host, and inside a cluster, maybe even dozens of different disk groups. So the domain of deduplication is quite small, and therefore the effectiveness of deduplication in vSAN OSA is limited. With vSAN ESA, that's totally removed. We're deduping the entire data store. And as I spoke about earlier, that could be petabytes in scale. That deduplication also works with the other technologies, right? It works with compression. It works with snapshots and clones. So as the writes come into our vSAN ESA data store, they're compressed upon write, they're distributed across the other hosts in the system, and we can also apply data in transit encryption as well. All of that's compatible with dedupe. One of the things that you might notice in the middle here is it runs asynchronously. That means that the dedupe process inside vSAN ESA runs after the data has been written and committed to disk. It's essentially a background process. So if there's a need to throttle back that deduplication process, we can do, but in a well-run cluster, the reality is that dedupe is running all the time in the background. The only capability that's missing from this slide that you might be aware that you've applied in your environment is data at rest encryption. Didn't quite make the VCF 9.0 release, but it's certainly being developed in the background, and everything I hear will be something in the next release. So data at rest encryption with deduplication for vSAN ESA available in the next release. So with vSAN ESA, let's have a quick look at licensing. Well, if you own a VMware Cloud Foundation subscription license, you already own vSAN storage effectively. You have a license to use that capacity. So for every VCF core, you're entitled to 1 TB of vSAN capacity. And on the right-hand side of this diagram is showing that if we have a vSphere cluster That vSphere cluster is licensed with VCF and contributes 1 tib of capacity. If we build out a vSAN storage cluster as well, every core on that also contributes capacity into the license pool. If you have a vSAN storage cluster that has more capacity in disk than you're entitled to in cores, we simply add capacity on. So really, it's included and bundled, and I'm having a lot of conversations with customers today that are now aware they've got this entitlement and are really starting to look and see and understand how they can deploy storage clusters inside their environment. So just an example of how that licensing might work for you. So what we have here is an example environment that has 288 VCF cores on it. So we are entitled to 288 TIBs of vSAN capacity. We build out a vSAN storage cluster that's got 128 cores. So maybe we've got a 4-node cluster with two 36-core CPUs contributing that 128 TIB of capacity. So combine those two, and we're entitled to build out a vSAN storage cluster of 416 TIBs of capacity. If we apply that dedupe and compression ratio, and we're seeing the very highest numbers that we've just spoken about, 5:1 or even 8:1, we're talking about petabytes of capacity, we're talking about petabytes of vSAN capacity just from an included license. When you think about that from a traditional array, that's really quite something. As opposed to going out to the market and having to procure additional hardware just to run storage, all we need to do is procure vSAN ready nodes, knowing that we have the software entitlement already added. What we're going to do now is sort of talk about just how vSAN can scale over the next couple of slides. And we can really start to see how powerful vSAN storage clusters can become. So when we're working with vSAN and vSAN HCI, and we're running virtual machines inside our vSAN cluster, we need to be aware that there has to be a limit into the amount of resources that the vSAN service can consume. We need to give as many resources as we can to actually run our virtual machines. There's no point vSAN consuming 20% of CPU. So we limit what the vSAN service can consume. And yes, vSAN is a highly performant storage system, but of course there has to be a cap. With a vSAN storage cluster, we can effectively turn up the amount of resources that vSAN service can use. So throughput increases, response time increases, and have a much higher level of performance across our vSAN storage cluster. So in the example here, perhaps you've got 12, 16 nodes of vSAN, 12 or 16 nodes of vSAN ready nodes contributing towards the cluster. So each of those are contributing resources. If we compare that to a traditional array, we might only have 2 controllers controlling all the disk shelves. And there's things that we need to be cognizant of. If we lose a single controller, we need to be aware we've potentially lost 50% of our processing capacity. But inside a vSAN storage cluster, we lose a single host in a 12-node cluster. We've just lost 1/12 of the capacity. So really, risk starts to be reduced when we're able to spread that compute power or the processing power across a greater number of hosts inside the system. And scaling up is really easy as well. I think typically when I'm looking at a vSAN storage cluster, I would probably seek to deploy a configuration that had at least 6 or 7 hosts inside the cluster. That would mean that the cluster can take a full advantage of the most efficient way of storing data. So really, we're looking at the equivalent of erasure coding for RAID 6. We'd also then seek to ensure that we have probably high capacity drives. I'm generally seeing that we have 7 or 15 terabyte drives inside a configuration. And we would always seek to leave additional disk slots free inside those hosts. What that means is when additional capacity is needed in future, we simply procure NVMe drives, we add them into the hosts, and assuming that we've got managed disk reclaim turned on, vSAN recognizes that new disks have been added, automatically claims those and adds that capacity to the data store. But it doesn't just stop then. The existing capacity and data is then split out and shared across those new drives, so additional levels of performance are added to that data store. It's also worth pointing out again a comparison to a traditional array here. And something I've definitely worked with customers on in the past is that when they've reached the performance capacity of an array, the process to go through to actually do a head swap or indeed a full array swap can be quite lengthy in time. And of course it can be done. But from a vSAN storage cluster perspective, all we need to do is bring a vSAN bring a new vSAN ready node into that cluster, add our 12th or 13th node, and again, we've instantly got additional performance and capacity added to that cluster. So we've spoken a bit about architecture and features. So how do we actually enable it, and how could I enable this inside my environment? So the process to go through is actually we use the same enablement process for a vSAN cluster. So we enable vSAN services. There's a prompt that we have vSAN HCI, a compute cluster that I'll cover in a second, or a vSAN storage cluster. There's then a second prompt that asks if it's going to be a single site or stretch cluster. And there's a small workflow then to go on and gather information about IP addresses and VM kernel ports. Once that's completed, the cluster is created, the vSAN cluster is created, and we're ready to serve out storage. One of the things you can see in the bottom half of this diagram is auto policy management. And I would very much encourage you to enable this. What this means is that if we start with a small cluster, perhaps of 4 hosts, vSAN will automatically choose the most appropriate storage policy for that cluster. In this instance, perhaps RAID 5. As we add more hosts to the cluster, we can have more efficient ways of storing data. RAID 6 and FTT equals 2, so failures to tolerate equals 2. We can provide much more efficient ways of storing data at a high level of protection. And so vSAN will alter its default storage policy to ensure that it takes advantage of those extra nodes inside the cluster. It's just one of those steps that really lowers the administration overheads for administrators of vSphere and VCF environments. But what about those client clusters I talked about? So very similar. There's a workflow. There's a workflow, and we can see we select vSAN compute cluster. And all of this then enables us to speak to the vCenter server where the vSAN storage cluster is connected to, and then it will mount that vSAN storage cluster data store, so a single vSAN data store, and then mount that to my vSphere cluster. So yeah, there's not a lot to it. The intention is it's meant to look simple, and it's just another feature and capability within inside vSphere. So although it's simple to enable, there are checks and balances that happen in the background. So those 2 processes that we just looked through, we built this out. You can see here, there's some good quality checks happening. We are ensuring that the latency between server and host is below 5 milliseconds. We're ensuring that we aren't connecting too many client clusters to our vSAN storage cluster. We're ensuring the versions are all compatible. So there's checks happening in the background, and anything that fails one of these will simply flag for us to fix before we create our storage cluster. So we've built it, we've added clients to it. So how does patching work for a storage cluster? Well, really the answer to this is the same as vSphere as well. If you're using vSphere Lifecycle Manager today, you use that same tool to patch your vSAN storage cluster. Generally, what we would see is a vSAN storage cluster will be kept up to date with the most recent updates, but we have flexibility. We know that customers might be in an instance where their vSphere cluster could be incompatible. Perhaps we have a management tool, a third-party management tool that hasn't yet been certified for the next release of VCF. Perhaps we've got a workload and our software applications haven't been certified on the vSphere or ESXi 9 platform. We can run a lower version on our vSphere clusters than our storage clusters if needs be. And remember, we've got quick patch as well. So with the recent release of VCF, we actually introduced an ability to patch our ESXi hosts without the need to put them in maintenance mode and without the need to reboot them as well. So the quick patch, in actual fact, the very first release, or the very first patch we released on the VCF 9 was a quick patch as well. So for those customers that did early adoption, they've already experienced this process as well. What it's doing is just making things easier to use, having less downtime windows potentially, and certainly easier ways to patch the environment. I spoke earlier on about some network topologies, and perhaps now we had a point of view on it. I would say that vSAN has always been fairly performant, has always been very performant from a storage perspective, but we've never really had an opinion about how to deploy networking for our vSAN configurations. Yes, it's been mentioned in the admin guide, but one of my colleagues, Pete Keeler, has done some really good blog posts over the last couple of months that are available on blogs.vmware.com that really go into some of our, I guess, best practices and opinions around networking within inside vSAN, and I encourage you to look at those. One of them that's talked about in one of those posts is network traffic separation for vSAN storage clusters. And what you can see from this diagram, what this diagram is seeking to show at the top half, is that our client clusters can actually sit on a separate network or have a different VM kernel port for our vSAN storage cluster. We're effectively creating a front end and back end traffic for vSAN. So all of our client clusters communicate with the vSAN storage cluster over the vSAN client VM kernel port. And all of the back-end traffic, so data resynchronization, replication traffic, and those meta updates all happen over a separate set of networks. What it means is that when there is potential for contention, that goes away and we can control it. So much better performance, throughput for both client and back-end traffic. We also have an opinion now about how we might deploy storage clusters within a rack and within an environment. So we think that a good architecture and a good design is probably to host all of your vSAN storage clusters in a single cabinet. What we're seeking to do is to keep all of that traffic on the same network, all layer 2, so therefore the top of rack switches, we can have a dedicated pair of 2,500 gig switches without the need for that vSAN backend traffic to traverse the spine in order to reach other nodes inside the environment. On the right-hand side of this diagram, you'll see an alternative one. Perhaps we can't really dedicate a rack to all of our vSAN storage clusters. We need to share that with some of our client traffic as well, or client servers as well. In this instance, again, we'd probably have a dedicated pair of switches for our vSAN storage clusters, and then connect those up then in order to top of rack. I think this serves two purposes. It keeps traffic off the spine, and also perhaps is a more favorable way to speak about this with the networking team, knowing that you're introducing a large amount of network traffic into the environment, that you can show them that you have ways and architectures of keeping that off that spine. So getting to the end now, and I said I would finally wrap it up by looking at hardware. So if you're used to vSAN ready nodes, yes, we have different guidance around our storage clusters. And we do have a fairly prescriptive set of standards. What we're looking to do is to ensure that we don't have poor configurations of vSAN storage clusters. What I mean poor is that we have a large amount of storage, perhaps not the compute power to actually work and process that capability. So for these 5 vSAN ready nodes that are SC, so storage cluster ready nodes, they provide a set of guidance around the sizing of our clusters. And yes, these will be worked into sizing tools, and you'll eventually see storage clusters within the vSAN sizer. But if you are looking at vSAN storage clusters, please get in touch with me. My contact details are in a couple of slides' time, or reach out to your account and technical team, and they can, of course, provide guidance around these as well. So that's all I wanted to touch on today. And there's a quick look at disaggregated with vSAN storage clusters. If you've joined a couple of these webinars before, you know we generally try and like to do a little bit of a demo now for 5 or 10 minutes. Unfortunately, due to VMware Explore, the hands-on labs are still offline until later on this afternoon. But what my intention is to do is to record a small demo. I'll add this onto the recording, and then have that uploaded to the webinar site. So you will be able to see a sort of a look and feel of the interface for vSAN storage clusters. So for me, just a couple more points. I think a couple of points of learning. Where would I go for more information? So if this has piqued your interest, where can I find out more? So the vSAN FAQs is a great resource. The vSAN blogs that I think I've mentioned a couple of times, do go and check those out. And of course, the VMware Cloud Foundation blog as well. Great sources of information. There's my contact details, and I will. This will be, of course, part of the recording. So do get in touch if needs be. Otherwise, I'll wrap up, and Carl, I'll pass over to you to close this call.
Perfect. Thank you very much, Duncan, for talking us through vSAN storage clusters. That was really interesting. I know we get quite a few questions around how to go back and watch the previous sessions. So there was a post I put in the chat relatively at the beginning of the call. So if you want to go back and watch any of the previous webinars, go through and do that. As usual, at the end of this call, there'll be a survey which comes up. If you can please, we really do read them, and we utilise the feedback for future sessions. So really appreciate if you can fill that in. The next webinar is going to be on Friday, the 26th of September. So I look forward to seeing you there. Just on the points of where to go to do learning. So as Duncan mentioned, the labs are coming on later on today, but there is a lot of new labs specifically around VCF 9. So I highly encourage you to go and have a look at those. And as usual, please, if you've enjoyed these, you go back and watch the recordings. Please spread the word, share it with your colleagues, any other sort of VMware peers you have or admins, then that'd be really great. So that just finally from me to say thank you very much from behalf of the UK&I specialist team for joining us today, and have a good weekend. Cheers all. Bye bye.